In diesem Video soll es darum gehen, wie die aerobe Stabilität von totaler Mischration auf Silagebasis im Labormaßstab bestimmt werden kann.
Depending on the feeding management, the total or partial mixed ration from silages and other components is prepared one or several times per day and is stored temporarily for several hours in a storage container or on the feeding table. This stimulates the microbial metabolic activity and thus the feed spoilage, especially at high ambient temperatures. Hence, there are products on the market which are offered to stabilize the feed ration. They are usually based on various chemical acids and their salts. An aerobic stability test on laboratory scale has been refined in order to evaluate the spoiling potential of silages or mixed rations. It is based on studies of Hans Honig at the then Federal Agricultural Research Center in Braunschweig in the 1980s. At the Saxon State Office, we differentiate the kind of feedstuff and include additional indicators for aerobic spoilage. This protocol is presented and explained in the following. The following questions and tasks shall be addressed in the trial. How strongly does the present ration tend to spoil? How is the effect of different TMR stabilizers in defined dosages on the aerobic stability of the mixed ration? Further questions could be: what is the effect of right experimental conditions, such as ambient temperature, for example? In our trial presented here, we are testing 3 treatments: negative control, untreated; positive control, treated with pure propionic acid; TMR stabilizer in question. First, the dry matter of the current TMR is determined. One option is the use of this rich fluid bed dryer, for example. For this purpose, a net of 50.0 gram TMR is weighed in. The material is dried at 105 centigrade for 15 minutes initially. Then it is weighed out. The net weight is multiplied by 2 to result in % dry matter. The material is further dried until the weight remains constant. Other rapid methods are, for example, the use of the defrost function of a microwave or an air fryer. In all cases, it means drying until achieving a constant weight. Another option is a determination at 105 centigrade in an air-forced drying oven overnight, that is sampling on the day before.
Die Trockenmassebestimmung im Vorhinein dient dazu, um zu wissen, wie viel Wasser hinzugegeben werden muss, um auf 40% Trockenmasse zu kommen. Diese 40% oder sagen wir mal zwischen 35 und 40 dienen dazu, dass tatsächlich aerober Verderb angeregt wird, denn mit zu hoher Trockenmasse haben die Mikroorganismen auch keine optimalen Bedingungen mehr. Haben wir jetzt am Ende 42% ermittelt, 42,8. Das heißt, laut unserer Tabelle sind pro Kilogramm der frischen TMR 70 Milliliter Wasser hinzugeben. Und da wir jetzt 2 Kilogramm TMR abwiegen, sind das 140 Milliliter Flüssigkeit auf diese Menge. Für den Aromenstabilitätstest im Labormaßstab nutzen wir diese KG-Rohre, DN 110 in diesem Fall, auf 20 cm Höhe zugeschnitten und die entsprechenden Deckel dazu für Boden und Abdeckung. Diese werden mittig mit einem 1 cm Durchmesser umfassenden Loch durchbohrt. Um Rieselverluste zu vermeiden, schneiden wir Verbandmull zu, einlagig. Das wird hier zur Abdeckung gegeben. So wird der Behälter zusammengesteckt. Wenn die Probe eingefüllt ist, kommt ebenfalls so ein Deckel wieder oben drauf.
Um die Temperaturverläufe während des Tests aufzuzeichnen, legen wir in diese Probe diese Tiny Torx ein, die kontinuierlich während der Lagerung die Temperaturen aufzeichnen. Die werden zusätzlich nochmal in eine Plastetüte eingepackt, um die Sensoren zu schützen und dann in diese Röhre eingelegt.
The numbers of the containers and of the loggers are entered in the experimental table. The combined weight of both is recorded. The room for storing the samples during the test run is tempered in due time. For mixed rations, a standard temperature of 25 centigrade is recommended to simulate summer conditions. At the beginning of the actual trial, the freshly mixed ration is fetched. You need material for 4 replicates, about 375 gram fresh matter each. Additionally, you need material for the dry matter determination for the microbiological and chemical analysis. In our example, we need 7 to 8 kg fresh matter for the 3 plant treatments. The current composition of the ration is documented properly. Ideally, it consists of at least 2/3 of fresh silage. Additionally, cereal grains, protein and mineral components can be included. This is followed by the sampling for the chemical and microbiological analyses. 2 to 3 samples, each around 500 gram fresh matter, are taken for the chemical analysis and frozen in labeled freezer bags at -20 centigrade. We recommend to analyze the fermentation parameters apart from the feed value. For the microbiological analysis, 2 to 3 samples, 40.0 gram each, are weighed in sterile stomach bags. They are temporarily stored at 4 centigrade and have to be processed within 24 hours to enumerate microorganisms. At least the total number of yeast colonies shall be determined. Germ counts of modes and aerobic bacteria give further information. For the determination of pH, 10 gram are weighed. 100 ml of distilled water are added.
Ja, jetzt werden wir die 3 Behandlungen vorbereiten. Eine Kontrolle, einmal mit Propionsäure und einmal mit Kaliumsorbat. Dazu wiegen wir je Variante 2 Kilogramm frische TMR ein, berechnen, wie viel wir an Wasser zugeben müssen, um auf 40% Trockenmasse rückzubefeuchten. Ich habe hier 99%ige Propionsäure. Diese nehmen wir als Positivkontrolle mit hinein. In mehreren Versuchen haben wir festgestellt, dass eine Dosis von 4,5 Milliliter pro Kilogramm geeignet ist, um einen stabilisierenden Effekt zu erreichen. Und da wir 140 Milliliter insgesamt haben wollen, gebe ich also 131 Milliliter Wasser hinein und 9 Milliliter Propionsäure auf 2 Kilogramm Frischmasse TMR. Ein Mittel, was wir testen möchten, ist das Kaliumsorbat als Konservierungsstoff. Davon werden 0,4 Gramm pro Kilogramm hinzugefügt, also sprich in unserem Fall 0,8 Gramm auf die 2 Kilogramm. Und wir brauchen 140 Milliliter Wasser, wie zuvor.
The PVC tube is filled loosely to about 1/3 with the sample material. The logger is then located in the center, and the container is further filled and then weighed. Thus, all treatments are filled in their replicates. The weight should be comparable with a tolerable deviation of 5%. Record the gross weight in the table. The tube is closed with a second cap. The PVC container is placed on a disc of polystyrene. The central notch channels facilitate the air exchange in the container. The container is surrounded by a collar of polystyrene. The encasement, 6 cm thick, of EPS 25 serves as a good thermal insulation. Samples are stored at 25 centigrade and removed after 72 hours. When all tubes are removed for evaluation, the caps are opened successively. Doing that, the degree of the production of condensed water is estimated on a scale from 0 to 4. 0 means no condensed water and 4 is the highest level, when wall and lid are dripping wet. On the surface, yeasts can already be recognized. Now all samples are weighed in the open container. Each sample is transferred on a vessel for further visual evaluation. When the sample is very moldy, an air exhaust and a respirator should be used. The data logger is extracted for later readout. Visible yeast and mold infestation is documented on a scale from 0 to 4, whereby 4 is a completely spoiled sample. This sample here shows a high yeast infestation and is rated with 3.0 points. This one only shows traces of yeast, thus 0.5 points. The pH value of the samples is determined using a freshly calibrated electrode to assess the increase compared to the original value at 0 hours. The dry matter content is determined in triplicate. After recording the gross weight, the samples are dried in the drying oven for 12 to 24 hours and weighed out thereafter. The tear of the shell is recorded. The data logs are read out. The time to reach 2 Kelvin above ambient is recorded, including the maximum temperature. We get at the evaluation. From the temperature data, the following is recorded. After how many hours was the sample 2 Kelvin above ambient? This time is a decisive criterion for the evaluation. In our example, there was a significant delay of around 20 hours by the additive compared to the untreated control. What was the maximum temperature difference? Here the additives reduce the delta by more than half. How many hours does it take until then? This helps to classify the proneness to deteriorate. In our case, it is a medium spoilage tendency. A strong heating would emerge already at the end of the first experimental day. The slope m from the temperature curves can also be compared. Here there is a clear incline from the negative control compared to the other treatments. The pH value at the time of removal gives another hint on the degree of the spoilage. It can extend into the alkaline range. Furthermore, the formation of condensed water, humidity. The visible infestation with yeasts. Here again we see a clear differentiation of the treatments. And possibly mold infestation. Last, losses can be regarded. This video showed how different TMR stabilizers and their dosage can be tested under controlled conditions in the feed. The method allows to determine the potential spoilage tendency of mixed rations treated differently.